Yeah, so let's look at the questions now. Okay, this is question 1. Already the topic is given to you, electrical system. Diagram below shows the top view of Beth's house. It's a toy house and a simplified circuit. There is a light bulb and a switch in each room. All the circuit components are working. So based on the diagram, identify one disadvantage of the circuit. Yeah, Jeremy, do the same thing. You can copy your answer and paste it in. Yeah, so that'll be easier. I think when I look at this answer, right, I saw how Joy actually wrote her answer. Okay, and then I saw Perez, I saw Salman, I saw Jared. You see, when I look at the answers that you put in, okay, so I can be sure, I think Joy knows what is the problem here. Okay, Joy already knows what is the problem here, but Perez and Salman, your answers are not clear enough, not specific. You only says it is in a series circuit. So if I'm someone who is looking at your answer, it is in a series circuit, I'll try to make sense of this. What are you talking about? And just in case you are not too sure how this diagram works, okay, you can see room 1. Room 1 is actually this room, okay, and then room 2 is here. Then you have room 3, yeah, and then room 4. So if I use another color, okay, this is actually the electrical circuit. So this is the wiring lah, they would say, the wiring in the house. So it's actually this particular purple line. So how they connect the wires and the lamp and the switches is actually like that, the purple lines. Okay, then they ask you what is the disadvantage of the circuit. You're only looking at the purple lines here. So what is the problem here with the circuit? Can you see, okay, look at Joy's answer. You should be able to tell. Okay, no matter which room you're trying to turn on the lights, right? Okay, what happened is, okay, you have to ensure switch 4 is being turned on. Can you see that? Okay, for example, if I were to look at, I use the highlighter, let's say room 1. So room 1, I would naturally turn on the switch in room 1, isn't it? But if I don't turn on the switch called S4, electricity cannot flow. Right now, room 1 cannot light up. The lamp in room 1 will not be able to light up. All right, so it is, sorry, draw the wrong one, should be here, this one, okay? If I were to try to turn on the lights in the bedroom 2, you will also see the same problem happening. Even if I switch on S2, if S4 is not being switched on, no electric current can flow. Okay, and it is the same for the third bedroom also. So when I look at Joy's answer, okay, let me look at the answers now. Okay, Delia. Okay, the light bulbs cannot be turned on separately. Delia, when you write this, still cannot give you full marks. Why is that so? It's not specific. What is the issue? What is the problem? But look at Joy's answer. Joyce said, when you want to turn on B1, 2, or 3, you need to turn on S4, which is true. S4 must be switched on. Yeah. Okay, so the switch there, S4, must be closed in that sense, in order for other bulbs in the other rooms to light up. So it is a criteria, S4 must be closed. So if S4 is not closed, no matter how you turn on the rest, it won't happen lah. Okay, you cannot light up the other rooms at all. Okay, so the floor here is actually S4. And I know actually what Perez and Salman is trying to say, but I cannot, okay, use my own interpretation to mark. So when I look at your answer, I'm behaving like a PSLE marker. So for Salman, I cannot give you the mark because you say it is in a series. What is in a series? You're not telling me. Perez as well. Okay. I know you probably know what is happening. It's just that you don't know how to phrase it in words. So if you refer to Joy's answer, I think this is pretty good. The only thing about Joy, your answer, when you want to turn on, okay, can you change this to B2 and then B3? Okay, because B1, B2, B3 is like bulb 1, bulb 2, and bulb 3. Okay, yeah. So if you just put down the numbers, they might penalize you lah. Be very careful. So Jaren also knows something. You see, Jaren says that it takes more than one switch to turn on at least one light bulb. Not specific enough. Not specific enough. Okay. Because usually, even if you turn on more than one switch to turn on at least one light bulb, it's not a particular big issue. But in a house setting, that is an issue lah. Okay, so Jaren, you have to be very specific. So now everything is dependent on S4. Okay, all the other lamps, whether they light up or not, is really dependent on S4. If S4 is not closed, no bulbs can light up. You can write that also. And then after that, right, for 1B, you need to propose, a certain arrangement. You need to draw a circuit to propose how she should be connecting the 4 bulbs and the 4 switches. All right. So the way to draw it, I know you cannot draw it in the portal. Not possible. So when you look at this question, the way to draw it, can you see? Okay, this is the highlighter. Good. Okay, so this is the proposed setup. I saw some of you wrote down, right? Parallel circuit. Someone says parallel circuit, which is good. That's what we want. Yeah. Okay, Alec, I saw your answer. Right? How come you removed it? Leave it there. Just let me take a look at your answers. Okay, so can you draw in your own circuit now? So when you check, okay, every single switch, right? Let's say it's this particular one, need to label also. This should be S2, this should be S1, this should be S3, S4. So each of this switch, when you turn, when you close them, yeah, you turn on the bulb. Okay. So when you arrange in parallel, it's easy. How do I make my box bigger? Okay. How do you make your box bigger? Okay, you can look at my screen. Can you see this? Okay. Where my mouse is, you see when you go to the side, yeah, you see the double line, right? Yeah, that's when you can drag. You can also make it smaller. Yeah. Okay, thank you. All right. So the next question. You have question 2 now. This is the energy question. John conducted an experiment with a rubber ball using the setup shown below. He released the ball at point A. Then the ball only managed to reach point O, should be point D, before falling back towards point C. He repeated the experiment several times and obtained the same results. State the energy conversion as the ball moves from A to D. All right, so let's see when I look at Delia's answer. Okay, good. Yeah, Joy, kinetic, okay. Yeah. Potential, kinetic potential. Okay, great. So the answer is yes. Potential energy, kinetic energy, and then potential energy. Okay, good. Yeah. So this part here, you seem to know, okay. When it's at A, before it's released, right, it has a lot of potential energy and it's actually at a certain height. Okay, once you release it, it will come down. As it comes down, it's gaining in speed. That's one thing. Another thing is also all the potential energy is converted to kinetic energy. Then at point C here, where it is the lowest, all the potential energy is converted to kinetic energy. That's why at point C, it is the fastest. Okay. Then when it goes to point D, because it only reaches point D, right? Never ever reach point E, yeah? So it will stop here before rolling back. So as it stops, this is the highest height it can reach. All right, so we have potential energy here. Now, let me ask you one question. Do you think when the ball is at this point, okay, let's say at this point of the setup, do you think it has potential energy? Some of you nodding, some of you wondering. Okay, yeah, Jeremy says, yeah, yes. There. I put the cross here. Yeah. So do you think it has potential energy? It is definitely moving at that point, right? Correct now. So it will have kinetic energy. But will it have potential energy? Yeah, Delia says yes. Someone says yes. Jeremy as well. What about Joy? What do you think, Joy? It was asked before. That's why I have to ask you. Do you know? Not sure. Not sure or don't have. Not sure means like that. Got means like that. Don't have means like this. Okay, not too sure. Actually, they have, okay, anything that is moving, especially moving upwards, okay, it is not flat on the ground, right? Okay, it has reached a little bit of the height. Okay, so it is actually gaining in potential energy and decreasing in kinetic energy. All right, so it moves the fastest here as it goes up. Okay, it will actually go slower and slower and slower and then stop at this point. Okay, and then it roll back again. Okay, you can't see just now, sorry. So at this point, it's moving the fastest, right? So as it moves up, it gets slower and slower and slower because kinetic energy is gradually converted into potential energy. Okay, until this point, all the kinetic energy it possesses already converted to potential energy. Some are actually converted to heat and sound. You know this, must know this. Any question here? No. Okay, good. Next, explain why rubber ball cannot reach point E. So if I look at your answers, very good. I saw, yeah, okay. Delia says some of the kinetic energy converted into sound, yeah, and heat. Yes. Okay, great. So some of the kinetic energy of the ball is converted, therefore, right. Okay, lesser kinetic energy converted. Yeah. Okay, good. It does not have enough potential energy at the start. Someone, can you explain to me what do you mean here? Okay, this one is good. Can I know what you are trying to tell me? Because I saw your answer, you said that it does not have enough potential energy. So, okay, because started off with not enough potential energy, so the ball will not have enough energy to reach point E, is it? Yeah. One thing I want to caution you is you said it. All right. So it refers to what?